and good morning to Dr. Wee. We are from Group 1G and we will present waste of chemical for green chemistry. Green chemistry is the design of chemical product and process that minimize or eliminate the use of hazard substance or their production. Green chemistry are also known as sustainable chemical. The purpose of green tea is first, to avoid pollution at the molecular level. Second, to reduce adverse effect on human health and the atmosphere from industrial product and process. And finally, to design and process chemical product to reduce their inherent hazard. Generally, bioenergy is energy extracted from any biomass. Biomass is a renewable resource and therefore has been considered an alternative feedstock for future clean energy supply. Example of biomass residue and waste are second-use cooking oil by converting it into biodiesel and plastic waste using pyrolysis method that are able to produce fuel, energy, and useful chemicals.
Next, I will talk about the challenges in the research fields. First of all, I will talk about the challenges in the biodiesel production from the waste cooking oil. Since the waste cooking oil is used as a feedstock, it will produce the less purity and it also will lower the yield of the biodiesel production compared to the fresh feedstocks. Next is the presence of the high free fatty acid, water and also contaminants in the waste cooking oil. The presence of the free fatty acids and also contaminants will lead to the undesirable side reaction during the biodiesel production. This results an increase in operating costs due to the need for an additional treatment. The presence of the water and free fatty acid also make them unsuitable for the homogeneous alkaline trans-esterification catalysis because alkaline catalyzed reaction is highly sensitive to them. Next, the challenges in this transformation is the immiscibility of the oil methanol, which can produce the low yield of the biodiesel productions. In order to overcome this problem, the mixing efficiency should be improved. And also, in this transformation, the usage of the catalyst in this process can affect the production of the biodiesels. Hence, the acid catalysts are less favorable compared to the base catalyst because acid catalysts need extreme conditions and also it will decrease the rate of reaction. Lastly, the challenges in this transformation is the use of the heterogeneous catalytic process. This is because heterogeneous catalytic process is mass transfer resistant, time consuming, and highly inefficient compared to the homogeneous catalytic process. Challenges in plastic waste into biorefineries. There are a lot of challenges in this transformation since pyrolysis is an energy-intensive process. The oil produced in this process required more energy to be refined compared to some other fuels. Next, the challenges in this transformation is the emission of the greenhouse gases. So, the pyrolysis oil may not be much better than conventional diesel or other fossil-based fuels. Lastly, the challenges in this transformation is the gases produced from the pyrolysis of some plastic waste are toxic. Therefore, the technology of the pyrolysis energy treatment is required, and also the pyrolysis oil produced need to be cleaned before it is used in any applications in order to reduce the environmental impact.
Real example, the transformation of the waste cooking oil into biodiesel and the transformation of the plastic waste into biorefineries. Used cooking oil can be used as the feedstock for biodiesel production because it is readily available, for example, from the restaurant or the household kitchen. some benefit of using used cooking oil as feedstock. It can reduce the cost of feedstock for biodiesel production. It doesn't require any additional plant culture. It can prevent the toxic discharge to the environment, and contamination problem can be reduced by reusing the waste. Biodiesel is derived from the oil that composed of monoalkyl ester. The higher the oil content of the feedstock, the higher the biodiesel production yield, hence lowering the production cost. It has been reported that the used cooking oil, mainly due to frying, contain more than 20% of fatty acid, which makes it more suitable to be the feedstock for biodiesel production, since it contains higher fatty acid. Step for biodiesel production: pre-treatment of used cooking oil with acid to reduce free fatty acid levels. After that, esterification of free fatty acid via mineral acid pre-treatment using sulfuric acid. And the last one is the best catalyzed trans-esterification of pre-treated used cooking oil to produce biodiesel by optimizing the influencing parameter to obtain approximately 94% of fatty acid methyl ester. The physicochemical properties of the synthesized biodiesel from used cooking oil must be obligate to the ASTM standards, which provide the minimum level of quality for biodiesel regardless fuel source. Next, transformation of plastic waste into biorefinery. Pyrolysis is a method that converts the plastic to energy, where this technique involves the chemical decomposition of organic compound through heating process, either in the absence of oxygen or in the presence of low energy, which will degrade the long-chain polymer molecule into smaller molecules. Pyrolysis reaction produce a mixture of molecules in the form of liquid or waste as the main yields, which depend on the process condition. Then the yields can be used as the feedstock for chemical or fuel refining. Pyrolysis method has a lot of advantage, such as reducing the volume of waste significantly, producing more feedstock for refineries by converting the waste into oil, gas and char, and it requires lower decomposition temperature and capital cost. It is a flexible method because the process parameter can be manipulated for optimization of product yield based on preference. There are 7 types of plastic which can be classified according to the chemical structure and the application. Type 1 is polyethylene terephthalate (PET). Type 2 high density polyethylene HDPE. Type 3 polyvinyl chloride PVC. Type 4 low density polyethylene LDPE. Type 5 polypropylene PP. Type 6 polystyrene PS. Type 7 others, which include the polycarbonate. Type 1, 2, 4, 5 and 6 can be pyrolyzed, while type 3 and 7 cannot be pyrolyzed. Several parameters should be considered as they influence the production of liquid oil in pyrolysis, such as temperature, type of reactors, pressure, type of fluidizing gas, residence times, and catalyst selection.
Next is the green chemistry principle related to the innovation. For the innovation 1, which is the transformation of used cooking oil to biodiesel, there are 3 green principles that has been applied. The first principle is principle number 7, which is renewable feedstock. It is considered as renewable as over 15 million tons of used cooking oil are produced annually. Next one is principle number 8, which is minimize or avoid unnecessary derivatization. The presence of alkaline catalysts such as CaCO3, NaOH, and KOH. Biochar from CaCO3 increase the catalytic capability. As a result, it enables the pseudo-trans-esterification to occur and lower the temperature needed for biodiesel production. Next one is the principle number 9. It is most selective catalyst reagent use. The specific catalyst used is CaCO3 from chicken manure. Specific catalyst helps to approach lower activation energy and enhance percentage yield and produce high purity of product. The production of fatty acid methyl ester or FAME from trans-esterification up to 95%. For the innovation 2, the transformation of plastic waste into biorefineries, there are 3 green principles that has been applied to the innovation. First is principle number 1, which is waste as feedstock. Plastic waste has been used as feedstock for pyrolysis process at different temperature to obtain energies. It generates waste into feedstock or closed loop that is more effective due to the potential to achieve a circular economics. Next is principle number 9, which is the most selective catalytic reagent. The specific catalyst used is zeolite, and the process is pyrolysis. The catalyst helps to increase the percentage yield of production, but it varies from the type of plastic waste. Production of PP type plastic is as high as 54% when catalyst is applied. The acidified catalyst is suitable for regeneration and low deactivating energy. Last but not least is principle number 11. It develops analytical method. It allows a control prior to formation of hazardous substance. The characterization using GCMS and FTIR to avoid the emission of unwanted and toxic gas into the environment. For example, carbon monoxide, NH3, and hydrogen cyanide.
Next, we will talk about the benefits and importance of transformation of waste cooking oil into biodiesel. Firstly, it will reducing the cost production since the waste of cooking oils are used as a feedstock to produce biodiesel, and it is much more cheaper than vegetable oils. And the next important is it will produce an environmental friendly product due to biodiesel is a non-toxic liquid and it doesn't require any additional plant culture. Other than that, it also will reduce the disposal concerns because mostly of this waste will be disposed in the sewage system, and it will cause a clogging of sewage pipelines, and it will lead to the malfunction in the filters and will cause oil or water separation difficulty. And then next, it also will avoid the repetitive usage of waste cooking oil by the consumer because this waste cooking oils produces a toxic content when it is oxidized from the fried foods, and this reusable waste cooking oil is believed to cause cancer, and it is dangerous to be reconsumed again by the consumer. Next, we will discuss about the 3 minus importance of this transformation of waste cooking oil into biodiesel. Firstly, it will offer additional income to the households, restaurants, and fast food outlets, as this waste cooking oil demand will be increased because it will be used as a feedstock of the transformation into biodiesel. Next, it will minimize the water contamination, hence it will preserve the aquatic habitat. And lastly, it will promote social inclusion by engaging youth in the collection of this waste cooking oil, and it will increase the job opportunities among the youth. Next, we will discuss about the benefits and importance of plastic waste management using pyrolysis method. Firstly, it will produce an environmentally effective products because all of these products and byproducts obtained can be useful in other processes. Second, it significantly reduces the volume of waste by 50 to 90%, and it also able to produce high amount of liquid up to 80% at moderate temperature around 500 degrees Celsius. Other than that, it will also produce environmental friendly fuel because it contributes in the reducing of carbon dioxide in the atmosphere. and it also easier to handle and flexible compared to the common recycling method, as the process parameters can be manipulated to optimize the product yield. And lastly, liquid oil production from this process can be used in multiple applications such as furnaces, boilers, turbines, and diesel engines without the needs of upgrading or treatment.
In conclusion, green chemistry is able to achieve by converting cooking oil into biofuel based on the principle of green chemistry. In addition, plastic waste can be converted into useful product through several process thermal treatment technology such as gasification, pyrolysis, plasma process, and incineration. Thank you.